Program Manager, HelioSwarm, NASA, Dr. Butler, Hine. And last but certainly not least, Space Systems Director at Fugro SpAARC. This crowd probably knows, but SpAARC is Australian Space Automation, Artificial Intelligence and Robotics Control Complex, Dawan, McIntosh. So it's an amazing panel today. At Curtin University, we pride ourselves on creating a positive and vibrant student experience that prepares students for life and work after university. The precinct that we're in today, this wonderful building and the surrounds, is a great example of that philosophy, bringing together educational facilities, accommodation and a rapidly growing range of commercial outlets. Although, as a chemist, I am obliged to point out that you will find different and exciting things all the way on a 1 kilometre walk south that ends at Building 500, where you can find chemists and other scientists from the University Chem Centre and the CSIRO working alongside each other. Through all of these activities, we strive to bring together teaching and learning, research and engagement with industry, government and community, where students sit at the heart of everything we do. The event today is a wonderful example of this. I thank the panel members for taking part, all of you for being here, and absolutely not to be forgotten, the awesome science and engineering student engagement team. You! Lurking around there and back there, who've done all the work behind the scenes to make this happen. Actually, give them a round.
Yeah.
With that, I'm delighted to declare this event open, and I will hand over to the Deputy Director of the Space Science and Technology Centre, the wonderful Renee Sayers.
Hi humans, it's lovely to be here. I'm going to really try, for those that know me, I'm Renee Sayers. I'm the Deputy Director, who don't know me as well, the Deputy Director of the Space Science and Technology Centre. I really like space. I really love sharing space and getting people to fall in love with space, and also putting space in the hands of others, and WA in particular. So this is a BFG for me right now. I went to NASA Ames about 6 years ago and lost my mind, and I still haven't recovered to the fact that we get to work with some incredible people here at Curtin, across Australia and around the world. And what's even better is that there's a lot of them that are actually coming to move here as well, as we're going to hear a little bit further. So. I will be your MC today, so if anything goes awry, watch for me. You might not see where I'm at, but I'll be the one directing us to other people who know what to do. Follow out the exits, you know the usual. It's so lovely to be in this brand new building, by the way. It's the first time I've been here as well, so this is really exciting. Mobile phones, usual thing. If it rings, I certainly will make a big deal about it. So if you're kind of keen to just keep it low key, that would be awesome as well. We've got a photographer here, so we're going to get through how much people have been swarming around our amazing guests today. This is a real treat to have them all here together, and so hence why I'm sure there'll be plenty of selfies and plenty of chats afterwards in our networking at the conclusion of today. So we will be going on a little bit of a journey together. We will have a chance to hear from these incredible panel members, and I will invite them to share a little bit of who they are, how they got to doing what they're doing, and what is keeping them busy right now, and also maybe what's exciting on the horizon for them on their next adventures as well, what they're looking forward to. And then we're going to open it up to you to do some Q&A. And so again, I make the point that these humans have come from a very long way away. We've been doing all sorts of events and panels and talks that are on a plane all the way up to the Pilbara to see just what it's like here in WA to run some incredible huge infrastructure projects from a very small control room with a couple of people and lots of screens. And for those that haven't heard of Fugro SpAARC, looking at running missions from deep space to deep sea, from deep sea to deep space, and so it'll work either way, anyway, all the way around. So we're starting to see the convergence of what was originally a identity here in Western Australia around our resources sector, around the technology and innovation that's used to help underpin a lot of our everyday lives here in Australia, kind of converging with the opportunities of space and how exploring space has literally changed the game for our everyday lives. And in particular, the thing that gets me really, really excited about today, so much so that I named my daughter after this, is the Artemis generation. And what's different with Artemis compared to Apollo, of which Apollo was probably one of the greatest camping trips, field trips of all time, right? I know that we get here at Curtin some of those little bits of moon dust in our labs. We've got some of our researchers who do some incredible work on space rocks and understanding a little bit more about the rocks here in our country and around the world. But it's about going together. Artemis is about going together, and it's that sustained and ongoing presence at the moon. And so it's not just this time around about what are the things that we can learn, which is going to be amazing, and we can bring back to help our lives here, but it's actually what do we do here already? How are the things that what problems do we solve here at scale and the scope with the suite of technology and teams that we see day in, day out? How can that help exploration endeavours? And of course, what are those questions that we are asking as we explore and as we build instruments to help us answer that? So, as SSTC is the home of the Binar Space Program, and I can see a lot of our crew here, we've just had a little rapid fire around our tiny little labs where we built WA's first spacecraft, and literally as we have been talking today, buttoning up the last 3 next for launch. I start to welcome our fantastic panel who do this day in, day out over decades. Their experience has spanned literally decades, influencing some really great and grand endeavours on the global stage. And so it is my absolute pleasure to get cracked into some gorgeous chats here today. I'm going to start with you, David, and then we'll go to Roger, and then I'm going to go to Butler, and then I'm going to go to Dawan. So, hi, do you want me to answer it for them? That'd be great. You'd be like, sorry, I'm talking to NASA right now. Thank you. Be right back. I did. Thank you for reminding me. So we're going to start with the distinguished leader in space exploration, David Korsmeyer, with roles in AI and technology. Your achievements include pioneering NASA's lunar rover, Viper, and is driving innovation in small satellites. So David, I welcome you here to Curtin University, and I would love to hear a little bit about who you are, what keeps you busy, and what gets you excited in your role at NASA Ames.
Okay, are we on? Yeah? My name's Vic. Call me Dave. I am the Deputy Director of NASA Ames Research Center. I've been at NASA since 1991, the 13th actually, so it's a kind of limited event. I have a PhD in aerospace engineering. So this is the engineering community, and there's a lot of different flavors of aerospace engineering, and I did several of them. I got the opportunity to go to NASA Ames. NASA Ames is one of 10 NASA centers. So everyone thinks, NASA's is homogeneous, maybe entity, or not. Everyone thinks we're all in Houston, we're not. We're spread all over the United States. In California alone, there's 3 NASA centers. Us, California, San Francisco Bay Area, that area. There's JPL, Edwards Air Force Base, we call it Armstrong Flight Research. That's where the shuttle used to land back in the day. There's Houston, obviously JSC. Houston, got a problem, but they're still there. Kennedy Space Center down in Florida, where we do the launching of the big rockets. Goddard Space Flight Center up in Maryland on the coast just above Washington, D.C. Washington, D.C. does indeed have our NASA headquarters. That's where all the money is printed. Pay attention to them. And then south in Virginia, there is Langley Research Center. And then in the center of the states, we have in Alabama, Marshall Space Flight Center, and in Cleveland, Ohio, on the shores of Lake Erie, is Glenn Research Center. So that's NASA. I never thought I always thought I wanted to work for NASA until I started getting in college and doing things and thought, oh, no, I don't want to work for big bureaucracy. That doesn't sound fun at all. But as I started to work more with NASA scientists and engineers, I thought, well, these guys actually have a little bit of a clue. And when I graduated, I needed a job. So I applied and got in, and it turned out to be the best thing I've ever done. Ames is a great place. It's a research center. It's actually 84 years old. Anybody here can do math? And you remember or think you know when NASA was founded, that doesn't add up. So NASA was founded in 1958. Sputnik, that means we were around before NASA was, and indeed we were. We were an aeronautics research center years before that. So we got adopted when NASA was founded. So that's kind of the history of things. For me, I like everything about space. I like everything about technology. I like everything about engineering. I have a big wind-up geek, and that just keeps me happy. So I got into doing things at NASA. I found that the beauty of engineering is you're just trying to solve problems. And you don't know what problems you're trying to solve, and that's also the beauty of it, because you never know what you're going to end up doing. But there is a huge breadth of research going on in the world for space science, for aerospace engineering, for various activities. And I invite you to join us as we go off and do things. I'm here for the talk this week at the Indo-Pacific Science, Space and Science. No, Space and Earth Conference. What is it called, Tom? Indo-Pacific Space and Earth Conference. It was very nice. Yeah, thank you very much. And so with that, I'm going to be done.
Thank you so much. David Korsmeyer, thank you for sharing. I think it was the Indo-Pacific Fugro SpAARC conference, I think it was. But I do like the bit of science that you got in there as well, David. Thank you so much for sharing. And one of the things that gets us really excited about building a small satellite program here at Curtin is that we get to do a lot of it in-house. We get to design, we get to build, we get to test, we get to break, we get to test again, and we get to break, and then work out how to fix it again. And it's all in service of these planetary missions. And so science is really at the heart of what we do in exploring our solar system. So thank you so much for sharing a little bit about that. With NASA as well. So Roger, I'm going to lead into you as the Small Spacecraft Program Manager and the amazing decades of experience you've had, and in particular an amazing mission, if anyone's heard of the mission Kepler, and in particular K2 and what they did with this spacecraft to achieve some different aims from the original mission outcomes, and some amazing things that we now know because of these incredible missions, and it was led by you for 7 years. So it's such a treat to have you here to share a little bit about who you are, what you do, and what gets you excited. And yeah, after seeing our little tiny lab, and you can tell for some of our cohort here today why we're just so thrilled to be talking this type of technology and science with you. So. Ladies and gentlemen, no boys and girls, sorry, I used to work at SciTech, that was the thing I used to do. So, ladies and gentlemen, everyone in between, Roger Hunter.
I'm a child of Apollo. I've been in space business ever since I graduated with my undergraduate degree in math and some other degrees in physics, and also when I was in the Air Force, some other political science military degrees. But my 45 years I've been doing this has been largely associated with the space business. When I was in the Air Force, I worked on a number of space programs. Some are classified I can't talk about. One of the jobs I had, I was a squadron commander for all the GPS mission. So you're welcome. Because when I was managing that program, it was when it was declared fully operational capable. And there was a 4-star general who was having some arguments with some other generals throughout the Air Force, and he got tired of those guys making it continually a R&D program. He says, I declare full operational capability. And of course, we had to tell everybody the rest of the world, this is when GPS had 21 on-orbit satellites and 3 spares. There were never any spares. We had everything turned on. And now there's 31 or 32 of those satellites up there. So that was a great mission. I loved doing that when I was in the Air Force. And like I said, my entire Air Force career was mostly a space business, except for one brief stint. I was at Pentagon, and part of my assignment at Pentagon, I was a speechwriter. I ended up writing speeches for generals and also preparing their testimony for Congress. I didn't like that job, but it got me the job as a squadron commander for GPS. And so you have to put up with that during your careers too, because sometimes you got to do crappy jobs to get good jobs. When I left the Air Force, I went to work for the Boeing Corporation, GPS again. Because Boeing builds GPS satellites, and they were also responsible at the time for the management of the ground systems that are used to control GPS. And so I ended up controlling a site. We had 250 people for Boeing supporting the Air Force in managing that constellation. And then one cold January night, I got a call from Pete Worden and Al Weston, who were the center director and one of the directors at NASA Ames, and said, we're building this telescope called Kepler. We need a program manager. Come help us. And I said, I know who Johannes Kepler was. What's his Kepler telescope do? We're looking for another Earth. And I say, you have my attention, tell me more. You only get one chance to work at NASA. You only get one chance to work on a mission called Kepler, to go look for another Earth and also look for other planets in this galaxy and characterize the menagerie of solar systems, planetary systems that are out there. And before I start talking about small spacecraft, I want to briefly tell you the 2 things that are most important that came out of Kepler. You have beautiful night skies in Western Australia, outside of Perth. Get out into the desert, look up in the sky. Every star you see, and this is because of Kepler, every star you look at has a planetary system. Every one. 40% of those stars have Earth-sized, this is a conservative estimate, 40% have Earth-sized planets in a habitable zone. The optimistic estimate was 70%, and that was earth-shattering for us. We had no idea that would be the final results from Kepler. We had speculation on what we would find, but that mission was rewarding, and we have rewritten a number of astronomy textbooks because of Kepler. So now I switched over to small spacecraft. I've been program manager for NASA's small spacecraft technology program for the last 7 or 8 years. We have a lot going on. If you were at the IPSAT conference, I did a quick brush through of all of the technology demonstrations we have ongoing and upcoming. Starling is launched. That's our first attempt at a swarm. Second attempt. EDSN went in the water because the rocket failed. So if you want to go find them, there's a bunch of spacecraft off the Hawaiian coast. Go do some deep sea diving, go find the spacecraft, do a little souvenir. But we decided we want to try a swarm again, and we're actually, Starling represents our next attempt at a swarm, but it's much more capable. We are moving in the direction of intelligent swarms, spacecraft that have much more capable software on board so that we can unleash the spacecraft from control from the ground and let the spacecraft do more of the decision making as far as task planning for any science objects of interest. Some of you in the presentation I presented this week at IPSAC saw something called DiskSat. We're reimagining and re-envisioning the CubeSat platform. We're now going to something that looks like a pizza or a Frisbee. We are already bending metal on that. We had successful critical design reviews just recently, and we're going to be launch ready with the new DiskSat platform in 1 August of next year. And it's garnered a lot of attention. The Space Force wants to play with us on that. They've signed the SpaceX agreement. They're going to provide launch operations for that. And then, of course, we have a number of other technology demonstrations coming up that are going to be working on those things that we need to do to make small spacecraft much more capable and make them a regular tool for NASA to use beyond low Earth orbit. We're sending spacecraft into a small spacecraft now into cislunar space, Marco went to Mars, and so we want to make that more routine than it has been. We want to make it the rule as opposed to the exception. So that's what I've been working on for the last 7.5 years. And with that, I think I'll turn it over to Butler.
Thank you so much. Sorry, I have to mute myself in between because I clearly am making excited noises. That's awesome. Thank you so very much. And we've also got Dr. Butler Hine, also from NASA Ames, who's the project manager for the HelioSwarm mission. So I'm going to let you tell a little bit about that, Butler, but also what was the things that got you excited in getting to the place that you're at right now, doing these really innovative missions, driving this type of technology innovation through these incredible missions that we're running. HelioSwarm's a little bit bigger than sort of maybe the smaller spacecraft missions that we've been seeing, but it would be so awesome to hear a little bit more from you. Hine.
Thank you. So I actually started, my classical training is as a scientist, and the eternal regret of my thesis advisor, I was drawn into the darker side of engineering. Choice after graduating from college whether I was going to join all my friends or the Voyager 2 spacecraft project, and chose to go to NASA. I had to listen to my friends talk about Europe for years afterwards, but I can almost guarantee to freak out any intern by telling them I was an intern on a spacecraft that is now well outside the solar system and traveling interstellar. It just shows you how old I am. Yes. So that was my background, and I was always drawn into the implementation side of things. I always wanted to do things that achieved the science. So that's what I was after in my whole career. And then the other arc of my career has been looking for technologies that enable something that we need on science. And so I've done that numerous times in my career. In the early days, I was working on planetary robotics. And I was actually part of the first planetary rover on Mars, the Mars Pathfinder project. And leading up to that, we had done numerous analog field tests in the Mojave Desert, in the Antarctic, in the Kamchatka Peninsula, where we would take mobility systems and try to do in situ science with them, because at that time in the mid to late 80s and early 90s, the science community wasn't convinced that mobility was important. Up until that point, we would land landers on Mars and then do everything from that one spot. And it actually took a lot of technology development to convince the science community that mobility was important. And so that was what I consider one of my proud moments in my career, was we actually achieved that and convinced the science community that mobility was important. We did the Mars Pathfinder mission, and then now you see we've done the MER mission, the Curiosity rover, working on Mars Sample Return. All of those are based on mobility, but that required a technology push to demonstrate the value of that. So that was one arm, was planetary rover. And then after that, I became interested in spacecraft design. So I started working on the hard engineering side of what we do, which is designing and deploying spacecraft. And I started with a skunkworks team that I actually put together. It was just 10 of us, similar to what Renee has in her lab right now, a small group, but with enough of the different skills to do everything you need to do. And we prototyped a lunar hover vehicle to simulate a lander. We prototyped an orbiter vehicle, and then we were given the go-ahead to actually build and deploy an orbiter around the moon. And that's where I met Dawan. Dawan and I worked on that mission together. And that was the Laddie mission. So it was a science mission to orbit the moon and gather information about dust and the exosphere, how the water migrates into the primitive shadow craters. But it also was a technology demonstrator, because we demonstrated the first laser optical link, communications link from the moon to the Earth. And that's an important technology that we need for the future. And then, so that was the second proud moment in my career, was the technology, the arc from the concept to the science implementation. And then the third one is what I'm working on now, which is a science mission that is enabled by swarm technology. And so we started that at Ames, developing technologies, core technologies for swarms. And then Roger's program is currently flying a mission that is a technology demonstrator for swarm technologies. But the one I'm working on now, HelioSwarm, is a science mission. So it's the next step once you get the technology in hand, and then you try to do a science mission. And this is a 9 spacecraft mission where we have a large mothership, about 800 kilograms, that carries 8 of these 100 kilogram small sats. They're mounted to it, launched on a launch vehicle, and then the mothership takes it from phasing loops, does a lunar swing by, gets into higher orbit, and then deploys these 8 small sats, which then fly in a configuration around it to make simultaneous, spatially diverse measurements of the helio environment to study and understand the charged plasma environment. So that's a mission I'm working on right now. We're in the early design phase. Year or two, we'll switch over into the development phase where we actually build the hardware, and then it's scheduled to launch sometime in 2021. That's the one I'm working on now. So those are the 3, if this one works, but those are the 3 proud moments of my career where I actually saw from the back of a napkin concept, I saw through the technology arc, through the mission arc, to the final science that we achieved. Saw that whole arc. It was the 3rd time I'm seeing that arc, and it's very gratifying to see that arc. It's really very attractive.
Thank you so much. HelioSwarm sounds like an epic, very, very cool mission. And Dawn, you're now living here in Australia as Space Systems Director for Fugro SpAARC. You were the PM and the project manager for BioSentinel. For Starling, you were deputy to Laddie, so you've got some epic experience running these missions in space. And you were set to be doing HelioSwarm. And yet here you are in Perth, Western Australia, 2 years now. So tell us, what was so awesome that dragged you away from these incredible opportunities to continue helping these interplanetary missions? What's brought you here to Perth? And tell us a little bit about that journey.
Yes, tell us about it.
We're so lucky.
It's because I didn't want to work with Dave. No, this has been such a fun week for me because I'm really surrounded by both my, I brought down my original family and get to introduce them to my new family, and when I joined this original family, I was basically committed to staying at NASA for my entire career and working with these 3 people and a bunch of really amazing teams over and over again for until they wouldn't let me do it anymore. And so that was the original plan, and it would have been an amazing plan because I loved every second of the 20 years I spent at NASA Ames. And we are all NASA Ames people. Roger supports represents headquarters, and he actually just sits at NASA Ames because it really is the best center. And so it really is. And then I left that to move to Perth and live here with all my great people. And it was a very, very difficult decision. It was a really hard thing to leave NASA, and I did not take that lightly or make a quick decision about that either. But honestly, it was one of those things where I got to build an amazing spacecraft, and I would have continued to do that. but I was really drawn to the idea of getting to build a thing that people were basically not paying attention to, which is a side of a life cycle of space projects, the mission operations side, which people pay attention to very late, or they give it not a lot of love and attention. And I thought, gosh, I'll just let all of you guys go off and focus on the sexy space side, and I'm gonna focus on the infrastructure and this side, because I'm gonna make your lives easier if I do so. And that's really the intent, honestly, it really is. Hopefully this makes your life easier, because the thing you're trying to do is really, really hard, which is why ops gets ignored, because everyone's focusing on the really, really hard first part before it gets to the really, really hard second part. And so, none of it's easy. In case I wasn't the message, that's the message. None of this is easy. But really, that's it. I recognized that this was something unique that's happening here in Perth, and that I felt like I could do more here and make a bigger contribution. And doing it in a country that obviously you guys have been part of space since NASA has existed, but you're still you are now in a newly emerging area where space is becoming a thing you can do as you graduate and as you start your careers and continue through your careers. And so being kind of like on the ground floor along with you guys, where you're all on the ground floor of doing this in Australia, I thought that sounded amazing. So I moved across the world and have no regrets. It's been great. But now I'm gonna make them come visit me every once in a while.
Thank you, Dawn. I was actually going to say, do you want to tell a little bit about what you've been doing with SpAARC now that you've done the move?
Yeah, okay. So yes, I'm working with SpAARC. We're building out this mission operations capability, and at the moment it currently supports both subsea and prepping to support deep sea or deep space missions. So we're doing remote operations of uncrewed surface vessels off the coast of Australia, and as well as ROVs off of those vessels. And then we're now prepping for our first mission, which will be with Intuitive Machines. Intuitive Machines has a mission called IM-1, which is going to be a lander on the moon. That's supposed to happen in the next couple of months. They're working to get their launch in place right now. And the first mission will be doing observation, taking data for them and collecting and watching intently. This is a big deal for them. It's a hard thing that they're trying to do, and so we're just staying out of their way. But after that, we'll be taking over second shift, emergency shift operations, and really helping them have successful missions on a really regular cadence. That's one of the big activities we have. We've got some work going on in NASA Ames later, and then we're also under the ROSE program. We were selected to do the early design work for a tiny lunar rover, like the little grandbaby of Viper. And so we're working on early design work for the Trailblazer lunar rover. That's
Thank you so much, Dawan McIntosh. So we just had a little bit of a run around, just very briefly, of some of the experience and your insights and definitely inspiration. And so we're going to pass it over to you for some of your questions. So while you're thinking of some questions, if you just raise your hand and just shout it out, we're all here to do that. Yes. Yes.
So one thing that Dave didn't mention in his sort of little definition of what we do at NASA Ames. NASA Ames was really the center that started CubeSats. CubeSats had existed, but they hadn't. They were the building of the CubeSat was the mission, not the actual thing it did once it flew. And so NASA Ames really launched the idea that CubeSats could accomplish real things. And so there's a huge amount of history in CubeSats and NASA Ames, and obviously that's something that matters to, if I look at the room, this third of the room. But it is something that we've been paying attention to for a long time. So just wanted to
Thank you so very much. In acknowledging that we have our and how much fun we have had over the years, and in particular with the support from the US Consulate. We actually had Ambassador Carolyn Kennedy on her first visit to WA. As we had crammed you all into our little labs, we had done the same. And the thing that we were really excited to
inspected the spacecraft and
The other thing that we learned from it was, this was something I brought to the team, was if you ever ask how many copies do you need of something, it's in, we did not lose any schedule because we had a second structure that we built. We immediately shifted to that structure.
The centers, we're now getting 225.
I'll start, but I'm sure we all have our opinions on this one. Academic achievement absolutely is valuable. Is it sufficient? No. Hands-on demonstration of capability is incredibly valuable, maybe even more valuable, to show you can actually do something, achieve something, you're part of a team. Even if it doesn't actually do what you thought you wanted it to do, right? Don't skimp on this. You want to see if you can grow from mistakes. That's valuable, but is that sufficient? Also, no. You want to see a lot of things, but one of the most important things that I've seen at NASA that is really the most valuable is the passion. And I know that sounds a little weird, and I feel a little weird almost sometimes saying it, but that truly is the thing that distinguishes a lot of people at NASA and why we're there and what we're doing. We're there, no offense to anybody here, but you know, I love bridges. I like bridges, they're very cool. I like trains, trains are cool too. I like aircraft, fabulous. I don't want to do that for a job. I don't wake up in the morning excited about doing it. It's interesting, I like watching documentaries on that stuff because I'm a geek, but I don't want to do it all the time. This I want to do all the time. I talk about it far too much, that's my I think about it all the time. So showing the passion, having the passion, that really differentiates, right? Because there's a lot of really smart people out in the world. There always will be, always will. They can do all sorts of fabulous stuff. Good for them. I want to do it here. I don't want to do it over there. So for me, that's the real differentiation.
Dawan, you want to jump in there?
Passion was gonna be my answer too, so, that was obvious, that consistent, not always consistent. The other thing I'll add to this though is, it doesn't have, so if you get a chance to do an internship, it helps, it'll help you know what you want to do, help you focus. But also if you express your passion by garage building stuff, or you express your passion by joining a team doing a thing, actually joining a team is a good skill to have, right? That's actually, we're a bunch of engineers, there's a bunch of engineers in the room. We all know our favorite thing to do is not talk to people. But you will do that if you're building a space station. You will talk to people constantly, you will argue with people, you will fuss at each other, and then you'll continue to try to get the job done. And so if you join a team and you try to do a thing, and even if it's not successful, you being able to describe that in your intern application, this team you're part of, your role in the team, the things that went right, things that went wrong, I think is really a huge differentiator, and are the things that when we read them, and we read lots of them, you're right, when we read them we go, we start nodding, oh yeah, that's good, that's what I do all day too, and I think that makes a big difference.
And a beautiful segue to our undergraduate spacecraft club team as well. If you haven't heard about it, it's only a few weeks old. Tristan up the back is looking after that at the moment. So if you haven't heard about it, go and speak to Tristan and exactly this experience that Dawn is talking about where
There's the formal internship, which is a very process-oriented thing. It's highly competitive. But that's not the only path, so there are other paths. If you're on a CubeSat team in college, that is also a path. If you get an internship with an aerospace company, that's also a path. And the thing to realize is the aerospace community is actually a fairly small community, and a lot of us know each other. And one of the ways that I will get interns frequently is I will have people I have collaborated with, professors, call me up and say, hey, I've got a great student. they're going to graduate and looking for something for them. And if I've worked with that professor before and I respect their opinion, if they tell me that's a good student, I trust them. So there are lots of ways into the community. It's not just one.
I know Tristan also had a question, and just grab my eye as I scan if you have one, and I'll come to you.
You mentioned that you were very excited from all of your work that you've done, and if you could think back, what is the project that you were most excited about, and could you give us details about maybe how long it took to build, how much it cost, and maybe some of the scientific challenges or like technical challenges that you might have come across?
Formal process. Roger represents a different type of NASA, which is fast and aggressive. So I'll describe the science side. You can describe it as fast and aggressive. And then there's the whole human spacecraft side of things, and that's a whole different piece. So in the science, the robotic science world, it's all about competing ideas from the science world. So NASA will advertise a topic, and the topic can be astrophysics, science, heliophysics, planetary, surface missions, any topic. And then they're basically calling for ideas, and teams will form, pursue the ideas, write proposals, get down selected, they go to another phase, study, write a proposal, and then they're down selected from there, and they want to go forward. The time frames are, for those, are basically a year or so for early design phase, and then you get to preliminary design reviews. So NASA always gates these things. Formal does it different. But in the gates we go through, you have an independent review board that is looking at everything you've done and assessing it, maturity, and then they give you ideas to change, or this is not going to work ever, or yeah, you're good enough to go. And then you go to the next phase, and then you go to the critical design phase. So that's maybe another 2 years, and then you go into actually constructing the hardware. So actually putting all the hardware in. And that, depending on the complexity, can take 3 years. And then you go into the final integration test and launch. That's typically a year, and then you go into operation. So end to end, once you're selected, it's maybe 6 to 7 years until you're ready to launch. And then your science mission is whatever it takes to achieve. That's one goal. That's the other goal.
Butler's right. We're the Space Technology Mission Director, one of 5 directors when NASA charters small spacecraft technology program to go fast. From authority to proceed to launch readiness, 2 years or less. That's how fast we move. You go to my office at NASA Ames. If you ever come by and visit. Right before COVID hit, I had 2 aerospace engineers show up at my office and said, "We have something new we want to show you." And this was disk sampler day. And of course, this is, like I said, right before COVID. And we got up on my whiteboard and we started sketching out the requirements and the design for disk tech that day. And then all of a sudden, COVID, we shut down. Those notes, those drawings are still on my whiteboard. I took a picture of it and I just left it there because I said, this is going to change things. It took us a little while because of COVID slowed some things up, but we entered authority to proceed in April of last year. We're launching. We're going to be launch ready in August of next year. That's how fast we're moving. And why? Go look at the democratization of space. It used to be the province of 2 countries, the United States and the former Soviet Union. Many countries are launch capable today, and many, many other countries are now spacefaring nations. We intend, from a NASA perspective, to still be leading. We have been chartered to lead. Matter of fact, I go around the world and I give talks all the time, and people want NASA to lead, and we intend to lead because we think that there is a necessity for good leadership for space missions. And we want to be part of that. NASA is going to continue to be part of that. But when it comes to life cycles that he was talking about, our charter, once again, is from authority to proceed to launch readiness, 2 years or less.
Did you want to add anything?
Was when the crew decided to ignore orders, mutiny, and then continue on and go back to rescue. That's where NASA is so disciplined, especially astronaut corps, is so disciplined about following orders. That's the only thing that was off in the book, was that I was forced to throw an antenna out. It's just not strong.
And those facilities in the movie, yeah, that NASA's facilities don't look like that. We work in very, very old buildings.
The culture was there. I believe Jim Green and Ridley Scott actually spent a bit of time together on that one. And I can't help but to notice that for these types of, sorry, I'm just building on this, because it does talk to culture. You do open your doors to share what it is about having that meatball, the NASA logo on things. And so I can imagine it is in the best interest to, when shown interest from Hollywood, to actually integrate that as a story piece, to get that hearts and minds piece. And maybe if I'm looking at you, David, from a sort of center manager point of view, like how do you respond when people are like wanting to come in and see things and get a sense of that culture? How do you manage that on top of all of the other things you've got going on?
So we'll tell anybody anything. Usually, no, we will. It's not usually exciting.
I think you've got some very beautiful wind tunnels.
No, I'm just serious, right? We'll come in and we'll tell them, oh no, that's impossible. And they'll go, yeah, but I really, really want to drive, a high-speed rover on the surface of an asteroid. And what? No, it doesn't work that way. So, physics gets in the way, they don't really care. So, we'll tell them everything. It's true, that was the one that really touched well on the cultural piece of NASA. But, they ask us to be science advisors, we'll have these science advisors. And then if we're engineering advisors, and then they ignore us.
I do wonder what the Australian Trailblazer mission is going to look like as depicted in a cinematic version. It's got a whole meter of drone. Yeah.
It's going to be a
The branding in the bar sheet is great because even their underwear had the NASA bar. But Dave mentioned we love the movie. Don't go watch a science fiction movie with a bunch of NASA engineers and scientists. Because you just sit there and pick it apart. You can't. It's for escapism. So it's just enjoy the movie. There's perchlorates in the soil and Mars.
Yeah. The moment he got it on his clothes.
It's and the whole thing on you and I'm like, what? And of course, the density of the atmosphere on Mars is much less than it is here. And so him getting blown across the surface of Mars like he did, getting hit with the antenna, like, we're laughing. That's not going to happen.
But it needed for the dramatic
But it's
narrative
more
arc.
drama. It's it's the typical thing where a hero is put against a situation that's impossible to survive. And as he puts it, I'm going to have to science the out of this. And that captures the culture of NASA. We want to science the S out of this. And that's what we do. And that part, I thought, was the best part of the movie.
Butler, I wasn't going to ask, but could Pathfinder ever be a useful tool again? As it was featured there.
It probably could have. What was wrong with that? We leave hardware on the surface and in space all the time. And the way NASA decommissions things, we intentionally cripple the craft. So that's something we do, and it's for safety purposes. You don't want residual fuel exploding and creating orbital debris. So we intentionally cripple things when we're done with the mission. But those are actual circuit cards in there. The problem is that by the time someone tries to use a NASA residual technology, remember that technology is usually 20 years old before we launch it. And then after it's been in space for 20 years, you're talking about someone reverse engineering something that's 40 years old. That's the hard to believe part. Use it, but it's still functional equipment. It's just very old, unless it's been intentionally crippled. And one of the things we do cripple is radios, because we don't want anything interfering with your spectrum. So we'll intentionally disable propulsion systems. We usually disable power supply systems or battery safety, and then we disable radio equipment. Those are the primary things we intentionally will short circuit, destroy, disconnect, just for one.
Which is a fun activity, but there's a theater just around the corner from NASA Ames, and whenever there's this geeky space movie that comes out, they rent out the entire theater, we all buy tickets, and then you can barely hear the movie. That's literally how this goes, like, which is super entertaining and fun for us, and this is why we can't be wrong.
I was just going to say, Butler, I can attest to the reverse engineering. I've had an ex NASA Ames engineer wire up a brand new Chromecast to a 14-year-old TV in my apartment. So it was a feat of engineering. I was very impressed. So well done for all of the.
Perth has captured one of the best NASA hackers recently. You have one of our best hackers.
Very over-qualified IT support at home as well. Have we got another question? Oh, so we're a very cool brand here. Dawn, you've got one already.